Hey everyone, and welcome. Think about the engine block in your car or the heavy iron pipes running under your city. Those massive, complex metal objects are everywhere. But have you ever stopped and wondered, how on earth do they make those things? Well, today we're going to pull back the curtain on one of the oldest and honestly one of the most important manufacturing processes in human history, the art and science of metal casting. All right, so here's the game plan. We're going to start with the absolute basics. What is casting? Then we'll get into how it all starts with something called a pattern. From there, we'll see how molds and cores are used to create the empty space for the metal. Then comes the fun part, the actual fire and pouring. We'll also explore some of the different types of casting out there, because it's not all the same. And finally, we'll touch on what happens when things go wrong in the quest for the perfect part.
So let's get right into it. What exactly is this incredible technology? I mean, it's been around for thousands of years, but it's probably more critical today than it's ever been.
Well, for those incredibly complicated, heavy-duty parts, the answer is casting. It is the absolute hidden hero of the modern world. It's the process that turns a bucket of molten liquid metal into the strong, reliable shapes that we depend on every single day without even thinking about it.
At its heart, the idea is incredibly simple. Think of it like making a Jell-O dessert. You've got a liquid, you pour it into a mold, you let it set, and then you pop out the final shape. The only difference here is your Jell-O is thousands of degrees hot, and your mold is a super tough, heat-resistant container. It's a process that's also sometimes called founding.
So where do you even begin? Well, long before you heat up any metal, you need a master plan. You need a physical blueprint for what you're trying to create. And in the world of casting, that blueprint is called the pattern.
So the pattern is basically a replica of the part you want to make. You take this pattern and press it into sand or another material, and that creates the hollow space, the mold cavity, that the liquid metal is going to fill. And these patterns can be made from all sorts of stuff, from traditional wood to super precise metal, plastic, or even wax.
But here's where it gets really, really clever. A pattern isn't a perfect one-to-one copy of the final part. It can't be. The people who make patterns have to basically predict the future, building in these tiny but critical adjustments called allowances. This is where the real science and skill of casting starts.
It's all about fighting physics before it even happens. You know metal shrinks when it cools, right? So you have to make the pattern slightly bigger. That's the shrinkage allowance. Maybe the final part needs a perfectly smooth surface, so you add a little extra material for machining later. You even have to account for the fact that you'll be tapping the pattern to wiggle it out of the sand. That's a wrapping allowance. For weird shapes, like a big U that might warp as it cools, you might even pre-bend the pattern slightly in the opposite direction. It's brilliant.
And we're talking incredible precision here. For example, if you're casting aluminum, you have to make your pattern exactly 1.6% larger than the final part you want. That's it. That number perfectly accounts for how much that metal is going to shrink. If you get that number wrong, the part's not going to be the right size, and it's basically useless.
Okay, so the pattern is perfect. Now it's time to actually build the container that's going to hold all that fiery liquid metal. It's time to make the mold. This whole step is about creating that perfect negative space, that void that the metal will turn into our finished object.
And a good sand mold is so much more than just a box of sand. It has to be strong enough to not burst under the immense pressure of liquid metal. It's got to be permeable, which means it has tiny pores to let all the hot gases escape, otherwise you get bubbles. It needs to withstand that intense heat without cracking. And this is a cool one. It needs collapsibility. It has to be just weak enough to crumble and break away as the metal inside it cools and shrinks. All right, so that brings up a really good question. Making a solid chunk of metal makes sense, but what about all the complex parts that are hollow on the inside, like a pipe or the water jackets in an engine block? How do you do that?
The secret is the core. Think of a core as another solid piece, usually made of specially bonded sand, that you place inside the main mold cavity before you pour the metal. The liquid metal then flows all around it. And once it's all cooled down, you just break the core out, and boom, you're left with a perfectly formed hollow section or an intricate internal passage. It's what makes the most complex castings possible.
Okay, the pattern's done, the mold is ready, the cores are in place. Now, for the most exciting, most dramatic part of this entire journey, taking solid metal, turning into a raging liquid, and pouring it into its new home. So if you look at the whole thing from a bird's eye view, it really comes down to these 6 steps. We've talked about making the pattern and then the mold. Step 3 is melting and pouring. Step 4 is just waiting for it to cool down and solidify. Then comes the shakeout, which is exactly what it sounds like. You violently shake the mold until it breaks apart,
revealing the casting inside. And last, you have fettling and inspection, which is basically cleaning up the rough casting and making sure it's perfect. Now, pretty much everything we've discussed so far falls under the umbrella of sand casting, and that is by far one of the most common ways to do it. But it is just one method in a huge world of casting, so let's venture beyond the sandbox for a minute. A really good way to see the differences is to compare sand casting to something like pressure die casting. With sand, your mold is disposable, which keeps the initial costs low. But it's slower, and you get a rougher surface finish. Die casting is the opposite. You use a super expensive reusable steel mold called a die. The startup cost is huge, but you can pump out parts like crazy, sometimes up to 800 an hour, and they come out with this beautiful, smooth finish, perfect for really detailed stuff. Now, if you need to make some of the most intricate, complex shapes you can possibly imagine, you've got to turn to a really special method called investment casting. You might also know it by its much cooler, ancient name, the lost wax process. The way this works is just wild. You start with a pattern made of wax. You dip that wax pattern into a ceramic goop over and over again, building up a hard ceramic shell around it. Then, you stick the whole thing in an oven. The wax melts out, it's lost, and what's left behind is a perfect one-piece ceramic mold with no seams. This is how we make things that seem almost impossible, like the complex blades inside a jet engine, or your fine jewelry, or even dental crowns. Okay, but what if you need to make something perfectly round and hollow, like a pipe, but you don't want to mess with a core? Well, for that, you can harness the power of physics itself with something called centrifugal casting. This is just brilliant engineering. You take a cylindrical mold and you spin it really fast. Then you pour the liquid metal inside. Centrifugal force just flings the heavy, pure metal up against the wall of the mold. Any lighter stuff, like impurities or gas bubbles, gets pushed to the center. So when it cools, you get this incredibly dense, strong pipe. And all the junk is in the middle where you can just machine it away. It's perfect for things like pipes and the liners inside engine cylinders. So, as you can see, casting is an unbelievably powerful way to make things. But it is not easy. It's this delicate dance between heat, chemistry, fluid dynamics, and just plain old skill. And because it's so complex, there are a million ways for it to go wrong. And the names for the defects are just fantastic. You get blowholes, which are literally bubbles of trapped gas frozen in the metal. A misrun happens when the metal cools down too fast and doesn't feel the whole mold. A cold shut is this nasty crack you get when two streams of liquid metal meet, but they're too cold to fuse together properly. And a mismatch is just what happens when the top and bottom halves of your sand mold don't line up perfectly. Getting a part with zero defects, that is the true art of casting. So that leaves us with a big question. In our modern world of amazing technologies like 3D printing and hyper-precise machining, where does this ancient, sometimes messy craft fit in? Well, the truth is, while those new technologies are incredible, when you need to make strong, complex metal parts cheaply and in huge numbers, casting is still the undisputed champion. It's just a powerful reminder that sometimes the most important innovations aren't the newest ones, but the ones we've spent thousands of years perfecting.